Good morning. Today we're starting space, and so I just want to show you where our notes are. Just as a heads up, we have a new bell ringer sheet. It's right there in the bell ringers folder. We are now in Unit 2 Exospheres. So if you click there, we're starting with the universe and all those stars. Right here are the notes. So if you click on that, open her up. This is what they'll look like. So we'll start off, we talk about laws versus theories. Laws explain what happens. They're simple. They do not change. They're written in stone. We know them to be true. And it's usually a single idea, like gravity. There's only really one part of that. Whereas theories explains how. So laws explain what. So what's going on? Let's highlight that. Whereas theories explain how or why something works the way it is. Laws don't do that. They're just like, this is what it is. Theories are, this is why it happens. They're complex and they can be changed as new information comes along. All right. They are also considered true because they are tested multiple times by scientists and you get the same results every time. And it's made with multiple hypotheses and multiple laws, I would say. So Einstein's theory of relativity, which is all about gravity, and the more gravity something has, the more, or the more mass something has, the more gravity it has, and that can warp time, actually, which is kind of a weird concept, but yeah, it's pretty interesting, actually. So theories are how, why, whereas laws are what. When it comes to the size of space, objects in the universe and their scale, the universe is the largest, okay? And it contains all matter and energy. Galaxies are inside the universe, and they're clouds of gas and dust that contain star systems. You have the solar system, which are stars with objects that orbit around it due to gravity. So our sun is the center of our solar system, okay? And we are in the Milky Way galaxy, and it contains all matter and energy. So if I click here, I can actually add images. We can search universe. Whoa. Don't like these pictures too much. You can actually, let's look at what this says. So the universe, it's like this wispy stuff. I usually make people draw it in your notes. There's a lot, I guess, like that. I feel like that's the Milky Way. I don't feel like that's a good picture. All right. So maybe we just draw it. So if you look at this image, the universe is just a whole bunch of wispy, all kinds of stuff. All right. So maybe you draw on here with the scribble wispies. The local supercluster, which is in there, is a whole slew of galaxies. Let's see what comes up when you search local supercluster. Local supercluster. Oh, wow. Ooh, look at that. Wow. Okay, so that's like the observable universe. You zoom in and you have local superclusters. Those are like a bunch of galaxies together. And then I guess this is kind of where we're at within that. Laniakea. IKEA's in there. Anyway, inside that, there's our local group, which is our galaxy, the Milky Way, and our neighbors. So like Andromeda is our closest galaxy neighbor. Okay, we zoom into us. This is what we look like. We're a spiral galaxy. All right, and then here's some stars that are close by to us. Is our outer solar system, where we have like the Kuiper Belt, which has, that's like where Pluto is and stuff like that. The inner solar system is where are like the inner planets are, like Mercury, Venus, Earth, Mars. Those are inner planets. Outer solar system, you have Pluto, the Kuiper Belt, you have Jupiter, Saturn, Uranus, Neptune, and then you zoom into us. This picture is freaking sweet. I love it. All right, delete. Save and close. All right. If you want to put that in there, I'm not against it. Anyway, so if you highlight, I would highlight contains all matter and energy. The universe does. The galaxy is a cloud of gas and dust. All galaxies are clouds of gas and dust that contains star system. And then solar system is a star system. So star with objects that orbit around it. Highlight that, and hopefully you have some really good picture right there. So space is big, very big. So we measure it. We use a measurement called a light year. And that's the distance light can travel in 1 year at 186,000 miles per second. What? Highlight that. And then also highlight that it's the distance light can travel. The distance. Make sure you highlight distance. It's a distance. It's not a time. Okay, a light year is the distance. So it's about 6 trillion miles. Okay, and so since space is so big, we use how far light can travel in a year as a measurement tool. Okay, and these are our notes for now. Okay, bye.